Okay, so our Schrodinger's model is either called the quantum mechanical model or the electron cloud model. You can use one name or the other. You don't have to know both, okay? We are on page, that's a very good question, 39, 39.
Yo, who's trying to bust me? Sorry, Miss Smith, the yoga waste thing didn't work in the day. So
Oh, okay, thank you for letting me know. Okay, so we're going to be watching a little video. And this video has, let's just make sure I've got my sound up. I do. Okay, too loud. And we might slow this down just a little bit because he talks very, very fast. So we'll go to 0.75. Okay, here we go. You don't have to write anything down for this one. We'll go over the sheet later. Okay, so you don't have to worry about writing anything down. Okay. All right. Now, if you're like, what the heck is a picometer? If any of you have done the scientific notation, a picometer is 1 times 10 to the negative 12 meters, which is, in standard notation, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 meters. Okay, 0.000000001 meters. So that's like a teeny tiny little fraction of a meter. Okay, very, very small. Yeah. Pardon me? We could turn it into millimeters. It would be 0.000000001 millimeters. Yeah? So that would be 1 times 10 to the negative 9 millimeters. So there we are. Okay, so what they figured was they were like, okay, here we've got an electron, and if we make it hit something, if we have an electron and it hits something, it behaves as though it's like Dalton's model, yes? The solid sphere, okay? Okay, so here's what they're finding, is they're finding that, okay, you've got this nice little hard sphere, yes? But all of a sudden, bleh, it's a wave. Right? You know, like light waves, sound waves. That's what it did. It's like, waves? Weird. Doesn't it make sense that particles should just stay particles? Right? But they don't. Electrons fall apart into waves. Okay, see that thing? That appeared in my first year university chemistry book, and it terrified me, scared the snot right out of me. Okay, it was just like, what is that thing, and what are all those things in there? Anyway, turned out we didn't actually have to solve it, but there's a lot of math involved in this particle wave nonsense. It's not nonsense, it's actually very interesting. Okay, so when he says do the math, this is the math. Like, it's crazy, it just keeps going. So that's the math for the easiest one. And Grace, you might want to pay attention to this because this has to do with the SP and Ds. So you remember those little boxes we put on our Bohr model? And we said this is a room for the electrons. In reality, the rooms look like that, which is a sphere. Or they look like that, which is like kind of like two balloons stuck together. Or they look like two balloons with a donut. Okay, and those are the rooms that two electrons can live in. Okay, do you need to know these shapes? No, not really. I just want you to have like a flavor of what's actually happening, right? I'm not going to make you, reproduce these or anything like that, but just have a flavor that this Bohr model is not the end of our knowledge about the atom. So, blobby shape, all of a sudden, particle. There it is. So you can see, if you want, you know how you might go to the hospital to get an MRI scan? That's made possible by these theories. If you want an electron microscope or a laser or rocket fuel or string theory or any of those things, they all require all of this theory. So very useful stuff, but very mind-blowing, because what are particles doing turning into waves? That just sounds crazy. Okay, so let's just see if there's anything in there that you actually need. So we have our older models of the atom. We have the planetary model. You really don't need to do any of this. The only thing on this page, and this is on page 40, okay, at the bottom of page 40, let's put a big star beside this because this is really the only thing you need from here, is that we have this is our electron cloud model. Yes? There's our electron cloud model. And at the center, we have the nucleus. And what is the charge of the nucleus? Positive. Okay? And you can see it becomes sort of like a little cloudy around the outside, hence the term electron cloud, but there is kind of an edge that you can see. Yes? So this electron cloud, there's our positive nucleus, what charge is the electron cloud? Chat with your partner about that. What charge is the electron cloud? Okay, this is easy. It is negative because look, electrons are negative. So the area of the nucleus is positive. Everything around it is you guys let me know when you're ready. I'm having a nap. No, I'm kidding. Sorry, I've been up since 3 this morning, so I'm like not at my most resilient. You guys need to engage a little bit, okay? I need some answers from you. So it's negative. All the space outside the nucleus is negative. And do you know why I'm making such a production about this? Because this is a test question that everybody gets wrong every freaking year. And you guys just don't pay attention to it and you get it wrong. Not my problem. I have drawn it to your attention. I have drawn stars beside it. I'm trying to make your life easy for you. Okay? There we go. All the rest of it, you don't have to worry about. Okay? Page 40.
No, I actually just searched it up on D3 one. I didn't even know it was a real thing. That was like a joke, but I guess
Alrighty. So that is the last of the atom models. And we are now going to go back to the periodic table. So make sure you have your yellow periodic table out. Okay. And we are going to go to page, I think it's 71. 71. You need one.
Oh no! You got Ellen. Oh my god, not Ellen. I fucking hate Ellen.
Myself and
I got Ellen. They got him up to it.
Yes.
You have to make that face. Oh.
Yeah.
Yeah. Actually, you watch.
Can you fill my dress?
You know, Ellen Jenner is such a movie. I didn't know.
Can I sit somewhere else for a week?
No,
Like, not with my friends?
I don't want my.
No, you get to sit there. Okay. Shh. Now, we are on page 71. Okay, 71. And we're going to learn about a couple more groups on the periodic table. 71, 71. So what we've got is we've got these guys here, which are tall. And if anyone would like to borrow a highlighter, or I also have some pencil crayons. If anyone wants to borrow a highlighter or some pencil crayons to shade it, feel free to do that. Shh. The other tall group are these ones. Do you see how these are a little bit taller than the middle? So the taller sections, those are called the main group elements. Okay, so the main group elements are on both the left-hand side and on the right-hand side. Both the left and the right. Now, you should know the name of the middle group because we've gone over it before, but maybe you've forgotten it because we haven't done it very often. What do we call that middle section? Those are the transition metals. Okay, so we have the transition metals, which are in here. Okay. And then lastly, we have the inner transition metals, which are down at the bottom of the periodic table. And I don't know if you remember the name of those two groups that make the inner transition metals. Once you've written those things down, see if you can tell your partner what we call this row and what we call that row, the ones with the two red arrows pointing at them. See if you can remember what to call those. So what do we call that top row? Those are the lanthanides. And what do we call the row below them? Look on your periodic table. Actinides. Now I'm not going to give you time to work on this right this second. We're going to move on to something else. We're going to move on to page 72. And we'll come back to 71 later. All right? So this is just kind of putting what we had in the previous one just together. Okay, so everything's kind of in one place. So like I said, if you want to color things with your own shading, this is on page 72. 72. Okay. We have the main group elements. Remind your partner where the main group elements are. Point to them on the periodic table. You should be pointing how many places? How many places should you point? 2 places. Do you see on this one they're green? Okay. Main group elements on this one are green. What are the gray ones called in the middle? The gray ones are the transition metals. Okay, so we have our main group elements. And we also have our main group elements. We have our lanthanides and we have our actinides. And what do we call group number 1? Group number 1 is called, this group here that goes down there, what do we call those? Alkali metals, but not hydrogen. Hydrogen is not a metal. Does that make sense to you? Like hydrogen is not shiny, it's not hard, it's not a solid, right? It doesn't conduct electricity, it doesn't conduct heat, so it's not a metal. But all the other ones in group 1 are metals, the alkali metals. Tell your partner what is the difference in the name between group 1 and group 2. Is that going to bother you? I'm just asking because she gave me this face like.
That was in English class last year.
Can we move on past it? Are we okay?
Yeah.
Okay, all right. Now, what is the difference between group 1 and group 2? Group 1 is the alkali, and group 2 is the alkaline. Not just the alkaline, but it's the alkaline earth metals. So group 1, alkali metals. Group 2, alkaline earth metals. What do we call the group on the very far right of the periodic table? Those are the noble gases, and right beside them are the halogens or halogens. Either way to say it is okay. What do we call the things that go side to side? Things that go side to side, those are called periods. What do we call the things that go up and down? Those are called groups. Okay. So what we're going to do here is we are going to draw a staircase on the periodic table. Okay? Shh, boys. We're going to ignore the metalloids for now, and we're going to draw a staircase. We're going to start at this corner here. Okay? So this is now on page 73. 73. Is everybody on page 73? Okay.
Yes.
Yes?
Yes.
Page 73. Okay, cool. We're at the top of the, oh, I just couldn't see it. I'm just going crazy here. Okay, we're going to start here and we're going to go down. And then we're going to go across. And then we're going to go down and across and down and across, down, across, down, across, down. And we have made a staircase. And the staircase separates two major groups of elements. See if you can tell your partner which two major groups it separates. Which one? The transition. So the transition metals are just these ones. The metalloids will actually lie right along the staircase. Okay, but we're going to ignore the metalloids for now. We're going to make it even simpler. We're going to say, pretend there are no metalloids. What kind of elements are on the left of the staircase? To the left of the staircase. Which way is left? Left is this way. What kind of elements do we have? Somebody said it. What is aluminum? Aluminum is a metal. What is zinc? Zinc is a... What is nickel? Nickel is a metal. What is sodium? Sodium is a metal. Everything over here except hydrogen. Okay, everything over here. And everything here, and here, and here, and here, and here, and here. Those are all metals. So to the left of the staircase, we have metals. What do we have to the right of the staircase? Noble gases is one group, but that's only these ones. The noble gases are here. What else is to the left of the staircase? All the non-metals, okay? So non-metals here, and here, and here, and here, and here. Okay, those are all our non-metals. So the non-metals are to the right of the staircase. Yes, yeah. And then what do we have touching the staircase? Metalloids touch the staircase. The only one that touches the staircase that's not a metalloid is aluminum. Okay? But we know, you guys know that aluminum is a metal, right? Because you just know it from life. Yes? But everything else that has a direct touch of the staircase is a metalloid. Now, you could kind of argue about astatine, but honestly, these elements down here are radioactive. So they don't really hang around long enough. They break down into smaller elements. They don't hang around long enough for us to actually figure out if they have properties of metals or properties of nonmetals. Right? So you're kind of like, you don't care. We don't really care a lot about that bottom right-hand corner. Yeah. They break down into smaller metals. So they undergo a nuclear reaction, not a chemical reaction. It actually splits the nucleus. Okay, so you end up with smaller atoms that have smaller numbers of protons and neutrons. Does that make sense? Yes. Okay, so we have our metals, we have our nonmetals, and we have our metalloids. You should be able to draw the staircase. Yes? So on a quiz or a test, you should be able to draw the staircase. Now we have metals and nonmetals, and we have some properties. A property is a characteristic. And before you read this list here, what I would like you to do is I would like you to tell your partner some characteristics of metals. Tell your partner some properties of metals. What are metals like? Don't look at the list. Just tell them things you know from your life. Yes. Boys, you are supposed to be talking about the properties of metals. Talk with your partner. What are they?
Metals, not metals, they are solid, skinny, shine. No, that's shine. It's hard. That's solid. Yeah, I mean, it's in your bones all right. I said it in bones.
You're just reading the list. That's okay. All right. So what I want you to do is I want you to think about some gold jewelry, maybe a gold ring. Yes? What can you say about that gold ring? That gold ring, what's its appearance like? It is shiny. What state of matter is it? It's a solid. It's not a liquid. It's not a gas. Okay? There is one metal that is liquid at room temperature. Do you know what it is? Mercury. Shh. You guys said you could work together.
Yeah, we could.
Now, density. If you got like a bar of gold, would it feel light for its size or heavy for its size? Heavy. Do you guys know what it means when something is heavy for its size? That means it is dense. So these guys have a high density, which means they are dense. Now, you remember last day we talked about the blacksmith, and they're hammering on the metal. Does it break?
No.
No. And that is our next property. And this word you need to learn. Vocab word. Malleable. Malleable. Malleable means they will deform when hammered rather than breaking. Okay? So if you hammer it, it just flattens out, but it doesn't break. Ductile means if you pull on either end, it will stretch into a wire. I had one grade 11 student who remembered it by saying, metals are ductile. They stretch like a duck. Which made absolutely no sense to me, but at the same time, that kid never forgot it, right? Because, I don't know, in his head, he had some, picture of a duck stretching. And so he remembered that ductile meant it's able to be pulled into a wire. It's stretchable. Are metals good conductors of heat? Yes. Are they good conductors of electricity?
Yes.
Yes. What kind of wires do you have in your home? Copper wires. Okay? Copper wires. And we have metal, pots and pans. Okay. Most of the ones for metals you probably know already. Yes? So if I said to you, what's the density of metals? You would say they are dense or not dense?
Dense.
Dense. If I said, are they shiny or not shiny? You would say shiny. If I said, are they malleable? You would say yes. Are they ductile?
No.
Yes. Are they good conductors?
Yes.
Yes, of both heat and electricity. Now let's look at our nonmetals. They're kind of like the opposite. Yeah. Yeah. They're dull. About half of them are solids, half are gases, and there's again one liquid. Who's the liquid? Bromine. Okay. Are nonmetals dense or not dense?
Dense.
Not dense. Vocab word, brittle. Have you ever heard of peanut brittle? Peanut brittle is like, it's sort of a candy that's made by, like you take sugar and peanut butter and then you caramelize the sugar and it turns into this very breakable stuff, okay? So brittle means if you hit it with a hammer, it will break. Glass is brittle, yes? Glass is made of silicon and oxygen, which is also sand. It's just in a sort of a different structure. Very nice. Very nice. So brittle means breakable. Okay, it will break or shatter when you hammer it. Okay, brittle. That's a vocab word. There's no opposite for ductile. You just say it is non-ductile. So this ruler is made of carbon and hydrogen and oxygen. And if I pull on it, does it break?
No.
No. And if I have a pencil lead, if I pull on the end of it, does it stretch or does it break?
Break.
It breaks. So non-metals, like this pencil lead, which isn't really lead, do you remember which element it is? Graphite. What's graphite made of? Graphite's made of carbon. Okay, so we got carbon there. So it will snap. So it's not able to be pulled into a wire. Nonmetals, are they good conductors or poor conductors? They're bad conductors, okay? There will be a quiz on this, okay? Regular quiz, I will give you this, okay? Enriched quiz, you just get a blank table. Yeah? Do I have the practice quiz on me? Let's take a look. Oh, practice quiz is in your thing. That's beautiful. Okay. Good, good, good. So, practice quiz is here. Okay, I will give you one that has like the categories on it though, so you can also try that version. So what I'm going to get you to do is I'm going to get you to do for homework number 2 on page 73. Let's write this down somewhere.
Does it have to be word for word?
No. Does not have to be word for word. Just get the general idea. Number 3.
Dylan, give that back. Two people. Dylan, give that back. Give that back.
And on page 75, do number 4. You're not going to do question 5 because you're going to save that for over the weekend. Okay?
I know. Like, 3 questions. Right, yes, I don't know.
And then for 76, I'm going to just have you do 8 through 12. We'll talk about the metalloids next day. Okay? Because I think we've talked enough for today. So page 76, numbers 8 through 10, 8 through 12.
8 to 10.
Okay, so take a few minutes, work through those.
Here we are.
Oh, yeah, and 71 as well.
Let's just do this first. This one.
So you can work on that for the rest of class. If you finish it, then you're done. Okay?
But there's a point. Okay, yeah. You may be curious.
Nope.
You should.
Hello, friends.
Yes. Bigger. Yeah, that's what I'm trying to do.
Yeah.
I'm not trying to do.
Oh,
Where's all of them? We're just coaching. Where is it? Oh, it's right here. What is it? I don't know. Let's just call it.
Sorry, I should put number 1 on here as well.
I'm just gonna look for it. That's draw. Draw it. Oh,
This page is
yo, that's so racist.
We'll talk about
I'm literally circling.
That was describing a situation, but it's not. It's not gonna try to. I will.
Use names.
I will give you challenge.
Yeah, I don't want to do that.
Yeah.
I always help controlling the thing. That's right.
Nope.
We have to get Floyd. Right here.
Okay, I'm gonna get rid of this because I didn't number it very well. I got the numbers wrong.
Yeah, but why so? No, no, you form not the great rap. Yeah, I said. Sometimes when we do this, we